The Trojan Asteroids, Trojans of Jupiter and Other Planets. Title: The Trojan Asteroids, Trojans of Jupiter and Other Planets. Introduction. The Solar System is home to a fascinating collection of celestial bodies, including asteroids, comets, and planets. Among these, a special group called the Trojan Asteroids holds a unique place in th. Cosmic landscape. Trojans are asteroids that share the same orbit as a planet, often gathering around stable points in the planet's orbit commonly referred to as Lagrangian points. In this article, we will delve into the Trojan asteroids, focusing on their connection to Jupiter and other planets in our solar system. Trojan asteroids, an intriguing discovery. The discovery of the first Trojan asteroids dates back to 1906, when Max Wolf stumbled upon these enigmatic objects while observing the orbit of Jupiter. Since then, Trojan asteroids have been disk off arid around other planets, including Mars, Neptune, and even Earth. The Trojans of Jupiter, a cosmic dance. Jupiter, the largest planet in our solar system, acts as a host to the most extensive collection of Trojan asteroids known to us. These asteroids share Jupiter's orbit, moving at roughly the same speed, and exist within the same orbital plane. It is believed that their formation is closely linked to the early stages of the solar system's evolution. The Trojan asteroids around Jupiter are divided into two main groups, the Greeks, L4, and the Trojans, L5. The Greeks are named after characters who fought on the Greek side during the Trojan War, w. How the Trojans derive their names from Trojan heroes. Estimates suggest that there are over 6,000 known Trojan asteroids, with a similar number yet to be discovered. They are believed to be remnant as from the early days of our solar system, dating back more than 4 billion years. Formation and stability. The intriguing question arises, how did the Trojan asteroids end up in these stable Lagrangian points? This phenomenon can be explained by the combined gravitational forces of Jupiter and the Sun. SA forces create a delicate equilibrium that allows the asteroids to maintain their positions in the Lagrange points. The gravitational pull from Jupiter helps stabilize the Trojans, preventing them from colliding with a massive gas giant or drifting away into outer space. Exploration and missions. The ambitious exploration of the Trojan asteroids commenced in 2007 with the launch of NASA's Dawn spacecraft. However, Dawn's mission didn't extend to the Trojan asteroids. It will survey and study these remarkable objects, shedding light on their origin and composition. Mysteries and scientific significance. Apart from their intrinsic beauty and uniqueness, Trojan asteroids offer significant scientific value. They act as time capsules, preserving the pristine material from the early solar system. Trojans serve as important indicators for understanding the dynamics of our solar system. Their distribution and characteristics can provide valuable information about the migration and scattering of objects during the formation of the planets. Trojans beyond Jupiter. While Jupiter possesses the largest collection of Trojans, other planets in our solar system also host similar groups of asteroids. For instance, Mars harbors a significant number of Trojans, albeit on a smaller scale than Jupiter. Neptune, the farthest gas giant from the Sun, has also revealed the presence of Trojan asteroids, although their numbers are relatively small compared to those surrounding Jupiter. Trojan asteroids have fascinated astronomers and scientists for over a century. These celestial bodies, named after characters in Homer's Iliad, have a peculiar orbit that coincides with certain ETS in our solar system. This article will focus on the Trojan asteroids associated with Jupiter, the largest planet in our solar system, and other planets that have been found to have these intriguing celestial companions. The first Trojan asteroids were discovered in 1906 by Max Wolf while observing Jupiter's orbit. It was noticed that these asteroids tended to cluster around what are known as Lagrangian points, specchi. Thickly L4 and L5, which are located 60 degrees ahead and behind Jupiter in its orbit. These Lagrangian points are stable positions where the gravitational forces of Jupiter and the Sun create a delta Kate balance, allowing the asteroids to maintain their positions. Jupiter's collection of Trojan asteroids is by far the largest known to us, with over 6,000 identified so far. These asteroids are divided into two main groups known as the Greeks and the Trojans. Greeks, located at L4, are named after characters who fought on the Greek side during the Trojan War, while the Trojans, found at L5, are named after Trojan heroes. It is believed that these asteroids are remnants from the early days of our solar system, dating back billions of years. The formation and stability of the Trojan asteroids can be attributed to the combined gravitational forces of Jupiter and the Sun. These forces create a delicate equilibrium that prevents the asteroid from colliding with Jupiter or drifting away into outer space. This phenomenon has puzzled scientists for years, and further research is being conducted to understand the intricate dynamics of the celestial bodies. Exploration of the Trojan asteroids began in 2007 with the launch of NASA's Dawn spacecraft. While Dawn's primary mission was to study other asteroids, it did not extend its exploration to the Trojan asteroids. However, the European Space Agency's Jupiter Icy Moons Explorer (JUICE) mission, scheduled for launch in 2022, will delve into the study of the Trojans. JUICE aims to survey and study the remarkable objects, unraveling their origin, composition, and their significance in the solar system. The Trojan asteroids hold immense scientific value. They act as time capsules, preserving material from the early solar system. The distribution and characteristics of the Trojan asteroids can also provide valuable information about the migration and scattering of objects during the formation of the planets. While Jupiter boasts the largest collection of Trojans, other planets in our solar system also harbor these peculiar asteroids. Mars, for example, possesses its own troop of Trojans, although in small numbers compared to Jupiter. Even Neptune, the farthest gas giant from the Sun, has been found to host Trojan asteroids, albeit in relatively small quantities. Trojan asteroids, which share the orbit of planets, have long fascinated astronomers and scientists. These celestial bodies, named after characters in Homer's Iliad, have a unique orbit that closely aligns with certain planets in our solar system. The discovery of the first Trojan asteroids can be traced back to 1906 when Max Wolf observed Jupiter's orbit. It was during this observation that he noticed a group of asteroids clustering around specific points in the planet's orbit. These points are known as Lagrangian points, specifically L4 and L5, positioned 60 degrees ahead and behind Jupiter in its orbit around the Sun. These Lagrangian points create stable locations where the gravitational forces of Jupiter and the Sun allow the asteroids to maintain their positions. Out of all the planets in our solar system, Jupiter is known to have the largest collection of Trojan asteroids, with over 6,000 identified so far. Scientists believe that these asteroids are remnant as from the early days of our solar system, dating back billions of years. The formation and stability of the Trojan asteroids can be attributed to the combined gravitational forces of Jupiter and the Sun. These forces establish a delicate equilibrium that prevents the asteroids from colliding with Jupiter or drifting away into outer space. The specific dynamics that allow the asteroids to stay in these Lagrangian points continues to be an area of ongoing research and exploration. In 2007, NASA's Dawn spacecraft embarked on an ambitious mission to study asteroids. While Dawn did not specifically study the Trojan asteroids, its mission marked the beginning of our exploration of